By 2015, researchers hit a wall. Stacking more layers was supposed to make networks more powerful, but in practice, deeper plane networks trained worse, not better. A 56-layer net had higher training error than a 20-layer one, a degradation problem, and the gradient signal vanished as it propagated back through dozens of layers. Depth, the very thing that should add capacity, was breaking optimization. ResNet's fix was beautifully simple. Add a shortcut that skips the layers. Instead of forcing a block to learn a full transformation, big f(x), let it learn only the residual, little f(x), and add the input straight back. Output equals x plus f of x. If the best thing a block can do is nothing at all, it simply learns f equals 0 and identity, which is far easier than learning an identity from scratch. Why does this work? The skip connection is an identity path, a clean highway through the block. In the backward pass, the gradient flows straight along it without being shrunk by the weight layers, so even networks over 100 layers deep can train. ResNet took us from tens of layers to over 1,000, and it won the 2015 ImageNet competition by a wide margin. The second pillar is attention. Where a convolution only looks at nearby pixels, attention lets every token look directly at every other token and decide which ones matter. Each token emits 3 vectors, a query, a key, and a value. The match between a query and every key gives a set of weights. A softmax turns them into a distribution, and the output is that weighted blend of the values. Distance no longer matters. The transformer combines both ideas. One block is multi-head attention, then a small feed-forward network, and crucially each of those is wrapped in its own residual connection with layer normalization. Attention moves information between tokens. The feed-forward network processes each token, and the residual keeps the original signal intact while layer norm keeps it stable. Then you stack this block n times. And here is the key link between the two ideas. Attention only scales to deep stacks because of the residual. Without that skip path, a tower of dozens of attention layers would suffer exactly the vanishing gradient collapse that ResNet cured. The residual is what makes deep transformers trainable at all. Every large language model, GPT, BERT, all of them, is a deep stack of attention held together by residual connections. So, 2 simple ideas. The residual connection, add the input back, and keep a clean identity highway so signal and gradient survive any depth. And attention, let every token talk to every other token, weighting what matters. Put them together, stack them deep, and you get the transformer, the architecture behind essentially all of modern AI. 2 ideas, endless impact.